All right, so welcome to your Easiest Pie YouTube stream. This is Yudesh from Easiest Pie, and today we are going to be going through some revision, and we're going to be looking at revision specifically related to the number patterns and to functions, logs, and inverses. And so what I would like to do is, before I begin, I just want to make sure that this live stream is going well. So I'm just checking my stream health, my analytics, concurrent viewers, and I'm just going to say hello in the chat. Okay, and please feel free to ask questions if you have any related to what I'm discussing. And feel free to put some comments into the chat as well. And so we are going to start. And what I'm going to do is I'm going to take you through the question itself, and then I will give you some time to look at it, and I will stream some lo-fi music just to give you a sense of relaxation. So just give me a second while I put the stream beats on. There we go. Okay. Right. Let's have a look at the question. Let's underline the key parts of the question. I'm going to do that in blue. They say the first three terms of an arithmetic sequence are -1, 2, and 5. 3.1, there's no mark scheme here. Just give me a second while I get the mark scheme. My apologies for that. I should have somehow brought the mark scheme in. By the way, this is from the SUP paper of 2018. This is where I'm getting this from. So let's just get those marks in there. Bring that there and put that there. So, okay, so we now have the mark scheme. And why is the mark scheme so important? Well, simply because the mark scheme gives us an indication of how many minutes we should be devoting to the question and the number of steps that we should be breaking them down into. So they want you to determine the end term Tn of the sequence. So that is not too difficult, but I'm going to give you a little bit of a refresher just in case you require it. So let's pull out the information related to arithmetic sequence. Okay, do I have it? Yes, I do. Well, this is what we know about an arithmetic sequence. Tn is equal to n plus Tn is equal to a plus n minus 1 times d. They then want you to calculate T43, and then they want you to evaluate the sum of n terms. Okay, now, right, so here's what I'm going to do. I'm also going to give you the sum to n, or the formula for sum to n, to help you along. So just in case you don't have a data sheet here. All right, so now I would like you to attempt 1, 2, and 3. That's 2 marks, 4 marks, and 3 marks, which is 7 marks in total. So what I'm going to do is I'm going to give you roughly about 4 minutes to have a go at all of these questions. If you're done, please put your answers in the chat. So 4 minutes. I'm also going to start to play the stream beats music. Right, so let's see if we can find them. Here we go.
Looking for royalty-free music. Discover
Okay, just a second while I hold on while I put this on here. The audio is from the speakers of Michael Mic. There we go. So the stream beats are on, and have a go. All right, so time is up, and with that in mind, let's just stop the music. And let's go for it. Okay, so of course, what I would suggest, what might be your first step, is of course you might write out, okay, you've got -1, you've got 2, you've got 5. And given that it is an arithmetic sequence, we need to find out what the common difference is. Okay, because we know that there will be a common difference with an arithmetic series. We should know that. Okay, and so in this case, if I go from -1 to 2, that's 3, and if I go from 2 to 5, that's 3. So I know that I'm adding 3 in both cases. And in that case, now I know that my D is 3, and my A, which is the first term, is -1. So then I just plug it into this formula here, right? So I can then say Tn, so the general rule is A, which is -1, plus n -1 times D, which is 3. I can then distribute this in, so this becomes -1 plus 3n minus 3. And of course, that becomes 3n minus 4. And that's my answer. So let's have a look at the model solution. So you can see it says 3n minus 4. All right, so that was easy enough. If we go to question 3.2, they then ask you to calculate term 43. So term 43 means where I see n, I'm going to put in 43. So this becomes 3 times 43 minus 4. And of course, this becomes 129 minus 4, which should be 125. Okay. And that's our answer for 3.2. And then lastly, they use the sigma notation. So maybe that might have thrown you a bit. But remember, sigma is just another way for saying calculate the sum. Okay. So they want from the sum from k is equal to 1 all the way to n of tk in terms of n. And so what I would do, and just to show you on the model solution as well, what you can do is there's multiple ways to do it, okay? You could have said, let me put in what I have here, okay? And that's the easiest way really, right? So you could say Sn is equal to n over 2, and we don't know what n is, right? It's general. 2 times A is -2 plus n minus 1 times my D, which is 3. I close my brackets. And then I just go around, or I go about simplifying this. So this then becomes -2 plus 3n minus 3. Okay, and I'm just going to bring this over here, right? Let's call this step number 2. Let's call this step number 3. So then I can say Sn is equal to n over 2 into 3n minus 5. Okay, minus 2 minus 3. And then I'll distribute that n over 2 in, and that becomes 3 over 2n squared minus 5n over 2. Okay, 3n squared over 2 minus 5n over 2. And so that's probably the easiest way you could do it. Another way that you could have done it was you could have said, okay, let me work out what I've got here. You could have then plugged that in. You would have gotten the same thing. Okay, that's essentially how you do it. Okay, and I see no comments so far. Just going to see if I have anyone joining. Okay, we've got 3 views. That's great. Wonderful. So if there's any questions around this, please put it in the chat. Other than that, let's move on. Now, here's an interesting question. I was quite fascinated when I saw this question. You've got a quadratic sequence with a general term Tn and it has the following properties. We know that T11 is equal to 125, and then they say Tn minus 1 is 3n minus 4. Okay, now that's an interesting one, right? And what you'll notice is this is number 3.4, and it's essentially flowing in from what we've done in this one. Okay, so that is a clue, or that's a big clue to you, because, well, I'm not going to give too much away, but that's, maybe you need to ask yourself, okay, what is this? Okay, what is that? Because if I had to maybe write down my quadratic sequence, I know the quadratic sequence would be T1, T2, T3. Let's say I went all the way to the end, and let's say the second last term was, well, the second last term would be Tn minus 1, and then the last term would be Tn. Okay, that is my clue to you. I'm going to give you the structure of the quadratic sequence to help you along, and I'm going to give you, well, as much relevant information as I feel you need. Okay, that's a bit small, so maybe we don't use that, right? Let's use a bigger one. Here is the information for quadratic sequence, for constructing a quadratic sequence. Okay. Now this is a 6-mark question, which means you need to give this a bit of thought. And here's what we're going to do. I am going to give you roughly around 3 minutes. 3 minutes to have a go at this, and then we will discuss it. Okay, and let me just put the stream back on. Okay, streaming, and go, have a go. Write down whatever you think comes to mind. Let's see if we can get as close to the answer as possible. Right, time is up. So let's stop the music and let's have a discussion about this. Now, you'll notice that this is how you would say an exotic question. Exotic means that it's tested in a way that you might not have seen before. Now, what we know, what if we took the first difference, right? Well, we know that the first difference would be T2 minus T1, T3 minus T2, Tn minus Tn minus 1. And this is what they told me. This is 3n minus 4. So in an indirect way, they told me that this is the first difference. Okay, they told me that that's the first difference. Now, of course, in the previous questions, we know that it's, well, if n is equal to 1, right, we know it's minus 1 and then 2 and then 5. So we can sort of populate that into, because I know that this is then going to be minus 1. It's going to be 2, 5, etc., etc., etc. Now they told me that T11 is also 125, okay, which is an important part of it. So in this case, the first way that you could do this, and I want to make this a little bit bigger, just to make sure you can see it properly, right? What we know is that if we sum the first differences, okay, that's T2 minus T1, right? What you'll notice is, have a look at this. You'll notice you got a minus 10 and you got a plus 10, right? Or a minus T10 and a plus T10. You got a minus T9 and a plus T9. You got a minus T8 and a plus T8. You got a minus T2 and a plus T2. So you'll notice that all of the middle terms cancel. Okay? Now, what does that tell me? Well, if I work out, so you notice I've got 29, 26, 23, that 2, T1 as well, right? That gives me 125, and that's how I'm going to solve this, okay? I'm going to solve this using that sort of property, right? And you can see, what is this? This is actually a sum. You can represent this as a sum of 10 terms, right? And that's the first term and that's the last term. Now, you're probably wondering, where did you get that from? Well, this is where I got this from. You might remember that there is another formula for summing arithmetics, and it's this one. Sn is equal to n over 2 into a plus l, and that's what they've done here. They've converted this because this is your a term, that's your l term. There's 10 terms, and then you say that. And of course, that becomes 155, and if I take it across, I then get T1 is equal to negative 30. So that's a very clever way of doing it. Very clever. Well, what's another way of doing it? Well, there's a slightly longer way, all right? And maybe this is the more complete way, but what you could say is, okay, I know that Tn is equal to an squared plus bn plus c. That is the general formula of a quadratic series. And then I can substitute and say, okay, what is Tn minus 1, right? So I know Tn is going to be this. That's Tn. But then I say, okay, what is Tn minus 1? And this is this thing here. So where I see n, I'm going to replace with n minus 1, right? And what I do is I end up with this. If I do it correctly, I get 2an plus b minus a. But I also know that Tn minus 1 is 3n minus 4. And these must be the same. So what I can do is I can match what I have here. In this case, I then get 2a, that's the coefficient of n here, that's the coefficient of n here. So I get 2a is equal to 3, I get a is equal to 3 over 2, and then I get b minus a is equal to 4. I know a is 3 over 2, so I then get b is equal to minus 5 over 2. All right? And then I can plug in the values of a and b, or the coefficients, right? For when n is 11. And then I can work out the c term to be minus 29. And then if I put it in here, I get the quadratic equation itself. And then I can work out t1 and I get minus 30. Now you could have done it either way. One is a bit longer. If you were able to suss this out very quickly, then you would have done it in this way. But if you had to go the long route, that's still perfectly fine. All right. So I just want to see if there are any comments in the chat. Okay, no comments thus far. All right. In that case, let's move on. That's a bit of quadratic. And so now let's go to the functions and the inverses, right? They say below are the graphs of f of x is equal to x minus 4 squared minus 9 and a straight line, g. Now, if we look at this, we know that this should be a parabola. It's a happy face parabola. So let's start to highlight what I know. If it's a happy face, I know a must be greater than 0. If you look at the turning point, it looks like the x coordinate of the turning point is positive and the y coordinate of the turning point is negative. It looks like I have two roots, both of which are positive. I have a y-intercept which is positive, and it shares a y-intercept with the straight line. Let's see what they say. They say a and b are the x-intercepts of f. E is the turning point of f. C is the y-intercept of f and g. The x-intercept of g is d. DE is parallel to the y-axis, right? So here I've got a parallel line. And what does that tell me? That will tell me that D and E will share the same x-coordinate. Okay, so let's have a look and let's do this in a step-by-step method. They want you to write down the coordinates of E, so they want the turning point. And if you look at this, this is in the turning point form. I hope you can see that. And if you can't, I'm going to refresh your memory. Right, let's go to functions. Let me bring out a little bit of a summary of the turning point. You'll notice I have my turning point formula here, right? So that's going to be a clue. They also want you to determine the coordinates of A, which is one of the roots. And then let's see, they say M is the reflection of C. M is the reflection of C in the axis of symmetry of F, right on the coordinates of M. So here's what we're going to do. Let's have a look at 4.2, 4.1. Let's see if you can work that out. Please put your answers in the chat if you dare, if you're brave enough. And I encourage you to do that. Then that tells me at least I know you're paying attention and you're doing the work, right? So for this, that's 2 marks and 3 marks, which is 5 marks in total. So I'll give you 3 minutes. I will start to play the stream and begin. All right, so we have come to the end of the time for this particular question. Okay, so I'm going to get rid of this because I don't think we need it anymore. Right. Now, if they want the coordinates of the turning point, we know that this parabola is in the turning point form. So what we're going to do is we're just going to put down the coordinates of E. So I'd say, okay, E, what is the x coordinate? So remember, in this case, we know that the x coordinate is going to be positive, right? Producing x minus 4. But remember, the turning point form, just to make sure you're not confused, is a into x minus p all squared plus q, right? And my turning point is in the form p and q. So I drop the negative there, okay? So that's why it becomes 4 and, well, in this case, negative 9. Now this makes sense because I'm expecting a positive x coordinate and a negative y coordinate. Okay, so hope that makes sense to you. Right. And I just want to see how my stream health is. Stream health is excellent, so good. Stream settings, and what is this? Send feedback. Okay, no need to send feedback at this point. So that is my answer for the first one, E minus 49. And let's go to the next one, 4.2. What do they want? They want the coordinates of A. Now what do we know about A? We know it is a root, or it is an x-intercept. And how do I find the x-intercepts? What do? I make y equal to 0. Now another way to sort of look at this is, well, this is the same as saying y is equal to x minus 4 squared minus 9, right? So I'm going to make that y equal to 0. So I'm going to say 0 is equal to x minus 4 squared minus 9. And I can solve for x in this case, so I'll take the 9 across, right? I can say x minus 4 all squared is equal to plus 9, right? Because remember, I'm taking it across. I then find the root of this side. And of course, if I root a number, if I square root a number, I'm going to have the positive and negative root. Okay, that's important because I will have two roots because there are two intercepts. So then what do I get? I get x minus 4 is equal to either plus or minus 3. Right? Now, if that's the case, I get that, then yet, if I take that minus 4 across, I get plus 3 plus 4, which is x is equal to 7. Or x is equal to minus 3 plus 4, which is then 1. Right? Now, in that case, this is closer to the origin, so this must be 1 and 0. And then b must be 7 and 0. All right, and that's how I do this one. Right, you can see I've done pretty much the same. There would have been a couple of ways you could do it. You could have expanded it and then you could have factorized, whichever way you feel more comfortable. Okay. Grim Reaper, which questions were the 3 minutes for? 4.1 and 4.2. Okay. Sorry if I wasn't clear about that. But now what we're going to do is we're going to go to 4.3 and let's see what they say about 4.3. They say M is the reflection of C, right? So let's find C. M is the reflection of C in the axis of symmetry of F. Now, what is the axis of symmetry of F? Well, we know it's that line that passes through the turning point, and this is known as the axis of symmetry, right? Now, if that's the case, right, it's a reflection in the axis of symmetry. What does that mean? Well, that means this is going to be where M is, right? That's what it means. That's the reflection of the axis of symmetry. Right on the coordinates of M. Now remember, in this case, we know that this line in yellow is going to be parallel to the x-axis. Okay, that's going to be my clue to do it. That's a 3-mark question, okay? And what I'm going to do is let's just put in the key information. So we know that this is the point 4 and minus 9, okay? So let's just remove this. We don't really need it anymore. And then let's look at 4.4 as well. right? They say determine the equation of g in the form y is equal to mx plus c. So they want the equation of the straight line as well. Okay. So if I wanted to get the equation of this line, right? Well, let's see what else we know, right? They say c is the y-intercept of f and g. The x-intercept of g is at d. And DE is parallel to the y-axis. Okay, now if that's the case, if I remove this, well, what do I know? I'm going to know some key information about D. It's going to share something with E. So that's 3 marks and 3 marks. So I'd like you to now try 4.3 and 4.4. And I am going to give you 4 minutes in total. Okay, have a go. Let's see what we do. Let's see how we get it. And let's put the stream leads back on. All right, time is up. So let's just stop the stream for a bit. sorry, the music, not the stream. And let's see. All right, so the first thing is they say M is the reflection of C. Step 1 for 4.3 is we've got to find out what point C is, right? Now, if that is the y-intercept of the parabola, then how do we find the y-intercept? Well, what we do is we let x is equal to 0, right? So in that case, my y-intercept, well, what is it going to be? It's going to be 0 minus 4, which is minus 4. Minus 4 squared is going to be 16, and 16 minus 9 is going to be 7, right? So in that case, my C coordinate is going to be 0 and 7. Okay, so that's going to be 0 and 7. Now that makes sense because I was expecting a positive y-intercept. Now, what is going to be common with point M? Well, what's going to be common and what's going to change? Well, we know that the x's are going to change because I'm going along the positive x-axis. The y is not, because it's going to be parallel to the x-axis. So we know this is going to be some value and 7. But the question is, how do we then find that value? Well, this point M is going to hit the parabola, okay? And the y value is going to be 7. So what is the x value going to be? Well, we can find out by plugging it in here, because we know the y value is 7. So we'll then say 7 is equal to x minus 4 squared minus 9. And then I'm going to solve for x, right? I'm going to bring that across. That becomes 7 plus 9, which is 16. That becomes x minus 4 all squared. And then I'm going to take the square root. And the square root of both sides, so 16 is going to be plus or minus 4. This is going to be x minus 4. And of course, from here, I can do something very similar. So I'm going to take the 4 across. So I then get x is equal to what? So plus 4 is going to be 8. Or minus 4 plus 4 is going to be 0. Now, this tells me I'm on the right track. Because I know the x value for this is 0. So that means the x value for this must be 8. Okay, so that's M87. And let's have a look at our answer. Well, you can see they say M87. Okay, and that's how you would have done it. That's how you would have logically figured it out. So if we have no questions here, I am going to just move it along. Now, what do they need, or what do they want here? Right, so now they say determine the equation of g, y is equal to mx plus c. So they want the straight line. And we know this is in the form y is equal to mx plus c. Now, what do I know about the c value? I know it is the y-intercept. So what I'm going to do is I'm going to start by saying y is equal to mx, and my y-intercept is 7. So that's 7. Now, another thing, if I look at this straight line, look at the angle that it's making with the positive x-axis. It's making an obtuse angle. Now, what does that imply? What does that tell me? I'm expecting my gradient to be less than 0. That's important. Now, do I have another point on this line that I can use? Well, they gave me some key information about D. Now, what do I know about D? D is an x-intercept. So I know y is going to be 0 in this case. And I also know that the x coordinate is going to be 4, because remember, this green line is parallel to the y-axis. So then what am I going to do? I'm going to substitute 4 and 0. Okay, and if I do that, I then get 0 is equal to 7 times m. No, wait, sorry, my apologies. Haha, I made a mistake there. Is equal to 4 times m plus 7. Take that across, I then get, well, if I work it out, I then get m is equal to minus 7 over 4. Now, that makes sense, right? Because I was expecting that. And of course, from there, I can then say, okay, what is my equation of the line? Y is equal to minus 7 over 4 x plus 7. Okay, that's how we do it. Okay, we seem to be running out of time here. But let's complete this question fully, right? That's that. Last 2 questions for the day. They didn't say, okay, write down the inverse. Write down the inverse. Now, what do I do with the inverse? right? I just swap x and y. Now what I'm going to do is, let's just rewrite our, so we know y is equal to minus 7 over 4x plus 7, right? Y is equal to minus 7 over 4 times x plus 7. That's going to be used to find the inverse. Just swap x and y and then make y the subject of the formula. And then for which values of x will x times f of x be less than or equal to 0? So we'll discuss that once you find the inverse. I'm going to give you roughly about 90 seconds to find the inverse. And then we will discuss the last question. Ready and go. Okay. And let's play the stream beats. All right, so time is almost up. Let's very quickly solve the inverse. Now remember, how do I find inverse? I swap x and y. So where I see y, I replace it with x. And this is then minus 7 over 4 multiplied by y plus 7. And now I've got to isolate the y. So I'm going to take the 7 across. I then get x minus 7 is equal to minus 7 over 4 multiplied by y. Now, the easiest way to then get y on its own is I multiply by the multiplicative inverse, right? The inverse of this is 4 all over minus 7. So I'm going to do the same here. So I multiply by 4 all over minus 7, right? And then, of course, what I get is I then get, well, I can bring the minus to the top, minus 4 all over 7, and I'm going to distribute it in, so that becomes times x, and then the minus times a minus becomes a plus, and the 7's cross cancel, so then plus 4 is equal to y. Okay. Minus 4 over 7x plus 4, which is equal to y, and that's what we have. Okay, so that's how I work out the inverse, nothing difficult there. And now let's go to the last part of the question, which might be a little bit difficult, but I'm going to take you through it. Okay? They say, for which values of x will x multiplied by f of x be less than 0? Okay? So in this case, what are they saying? They're saying x times its corresponding y value, and this, in your exam, what you would need is your ruler. Okay? So you're going to pull out your ruler, and then you're going to bring it to vertical. Okay, so it's going to be completely vertical here. And now I'm going to give you an example, and what I want to do is I want to maybe remove some of the stuff that might confuse us here. So let's remove all of this. We don't need it anymore. Okay. But in this case, what we look at is we look at critical values, right? Now, and I'm going to extend this a little bit, right? So I'm going to extend this graph. Remember, this graph is going all the way to infinity. All the way, right? Now, let's say I took a value of the parabola here, right? Think about what, and let's call this point 1. Think about point 1. What do I know about the x And what about I know about the y? Well, you can see that the x is on the negative side. So I know my x is going to be a negative. What do I know about my y? That's going to be a positive. And of course, if I multiply this, what do I get? A positive times a negative gives me a negative, right? If I move this, and let's say I brought it here, right? Let's say I took this green point here, number 2. Let's call it number 2. Number 2. What do I know about my x? Well, my x in this case is going to be positive. What do I know about my y? Well, my y in this case is going to be positive as well. And that gives me a positive. What am I looking for? Less than or equal to 0, right? So what you're going to be doing is you're going to be shifting that ruler around, right? And generally what we do is we shift the ruler in a way where we look at the critical values, okay? Now in this case, the critical values are mostly related to where the sign of the x, so be it positive or negative, or the sign of the y changes. Now, where is that happening? Right, let's highlight it in red. It's happening here, it's happening here, and it's happening here, right? So we know that this point is where x is equal to 0. So let's work this out like so. And I'm going to do this in blue because this wouldn't be a working out, right? But if I said, okay, between negative infinity and 0, what's happening? Well, we know that the y is positive and the x is negative. So I know I'm getting a negative, okay? What's happening between, and remember, at 0, what's going on? That's going to be 0 because I'm multiplying by 0, okay? So that's the one. Now let's go from 0, right? Now what's happening between 0 and 1? Then I've got a positive y and a positive x. And a positive times a positive gives me a positive. Okay? Now let's go from 1 to 7. What's happening here? Well, now I've got negative y's and positive x's. So that gives me a negative. And from 7 onwards, so 7 to infinity, what's going on? I've got positive x and positive y, which is that. Now, if I think about it, if I include this and exclude that, right, because we can never include negative infinity or positive infinity, okay, and if I include this and include that, those are my solutions, because remember, this is at 0, and they're asking where is it less than or equal to 0, okay? So that's going to be your answer, right? And you can see how they've said it. X must be less than or equal to 0, or x is between 1 and 7. And we've simply written it in a different notation, but that would be accepted in any case. And so that is my answer to you for the last question. Remember, you'd use your ruler. And so this concludes the session as well. So I really hope this has been of benefit to you. We do this every week. We will do it next week as well. Is next week a public holiday? I just want to check. No, it's not. But the 27th is a public holiday, and we might shift it, okay? But I'll see you next week, and I'm going to end the stream here. If you have any feedback or if you'd like to be added to the WhatsApp group, actually what I'm going to do is I'm going to put the WhatsApp, well, please contact me if you'd like to be added to the WhatsApp group, okay? And I hope this has been a benefit, but I'm going to end the stream here. Thank you so much for attending. Wish you all the best. Ciao.